Okay, so here's the video for working backwards with z-scores. So sometimes in a z-score problem, you're given a proportion, percent, or percentile, and you're asked to find a value. So for example, here's an example of a working backwards problem. Suppose the IQ scores of students at a certain college follow a normal distribution with mean 115 and standard deviation 12. What score would you have to get to be in the 90th percentile? So in this case, it's not asking for you to find a percent or percentile. It's asking what score would you need to be in a certain percentile. A regular z-score problem, like the ones that we've been doing, would look more like this. So same situation, but now it's asking what percentile would you be if your IQ is 120. So the given information is a data value, and what you're asking for is a percent, or percentile in this case. So the difference is what information you're given and what you're asking for. So working backwards, you're given a percentile proportion. You're asked to find a score. Regular z-score problem, you're given a data value. You're asked to find the proportion, percent, or percentile. Okay, so in order to do this, we need to find particular z-scores for certain percentiles, and then we can use our z-score formula to work backwards. So looking at this first one here, the 75th percentile. So it's best to kind of sketch a picture with the 75th percentile. So we have to remember that percentile means to the left. So that means basically the area to left should be 75%. So if we know that halfway is about 50%, 75% would be just a little more. So this would be the area 75%. And to figure out what the z is for that, we're going to type in our calculator, 0.75. So in this case, since we're working backwards, so first of all, we need the area to the left. And now, since we're giving the percent, we're going to type it in here. So 75th percentile is 0.75. And the z-score for that is going to be 0.6745. So that's for the 75th percentile. Okay, the next one says 65% less. Okay, so again, we're going to sketch a distribution. We know that halfway is 50%. 65% less, that means to the left. So the area to the left of my line is going to be 65%. So I don't know, somewhere around here, it's just an estimate. And we're shading our picture. Remember, we shade our picture so when we put it in GeoGebra, we know that we have the right area that we're looking for. So now we're going to find the z-score that separates the 65%. So again, we're working backwards, so I'm going to change this to 65%. That gives me a z-score of 0.3853. And if you want to round to two numbers after the decimal, that's fine as well. All right, C, it's asking for 75% greater. Because in here we see that 75% of all observations are greater than Z. So greater, that means to the right. So here's my distribution here. That means we want our area to the right to be 75%. So that's going to be something along these lines. So this area to the right is 0.75. So now we're going to go to our calculator, and now we want to change the area to the right, and we want that area to be 75%. So 0.75, that gives me negative 0.6745. As we can see here, when we're on the left-hand side, our z-scores are negative, and when we're on the right-hand side of our line, our z-scores are positive. Right, now we're looking for D, which is the top 5%. So again, I'm going to draw my distribution. Top means to the right. So that means I want my piece on the right to be 5%. So something along these lines. Here's my middle. So 0.05, remember 5% as a decimal is 0.05. So I want my area to the right, and I want this to be 0.05. Is going to be 0.16449, or 1.6449. Okay, so now let's see how we're actually going to use those values in a problem. So this problem says high levels of cholesterol in the blood increase the risk of heart disease. 14-year-old boys, the distribution of blood cholesterol is approximately normal with mean 170. and then standard deviation of 30. And this boy, we want to figure out what would their cholesterol have to be in the 90th percentile. Okay, so I know this is a working backwards problem because it gives us a percentile and we're asking for a data value for a particular individual in our distribution. So here's the information. So first thing we're going to do, like with all even the regular z-square problems, is we're going to sketch a picture. There's the 50%. So 90th percentile, we know percentile means to the left. So I want my piece on the left to be 90%, which is maybe about this much. So first thing I need to do is figure out what that z-score is. So this area is going to be 90%. So select to the left, less than, and I want that area to be 90th percent. So the z-score is 1.2816. Okay, so now we're just going to work backwards with our z-score formula. So our z-score formula is our data value minus the mean divided by the standard deviation. Well, we have all this information now except for the data value. We have z, so it's going to be 1.2816 equals, we're solving for x, the mean is 170, divided by the standard deviation, which is 30. So now we just have to do a little bit of algebra. We're going to multiply both sides by 30. So 1.2816 times 30 is 38.448. Okay, now we're going to add 170 to both sides. So add 170. That gives me 208.448. All right, last thing was we should always answer in context. So I would say for a 14-year-old boy to be in the 90th percentile, his blood cholesterol would have to be 208.448, and the units are milligrams per deciliter. All right, so there's a working backwards problem. So in this case, instead of using the formula to find the z-score, we're working backwards, so we have the z-score and we're going to use the formula to find the data value.